Okay, here's the Module 9 notes, probability rules. This is page 7 and 8, actually. Two events are independent if knowing the outcome of one does not provide any information about the outcome of another. And we've talked about these at this point. So independent events are unrelated. So if I'm looking at the probability that I have a child that is female and the probability that that child is born in May, there may be some slight overlap if the numbers of female is different in May than the rest of the year, but they're roughly don't affect each other. Those are independent events. Okay. We've got events that are disjoint if they cannot occur at the same time. Again, these are mutually exclusive. Disjoint events would be choosing a student out of a high school. I'm looking at the probability of a freshman versus a sophomore, the event of choosing at random a freshman versus choosing a sophomore. There is no way that a student is both a freshman and a sophomore at the same time. Those are disjoint or mutually exclusive events. So we talk about independent, we talk about disjoint. So the question usually comes up as to whether or not disjoint events are independent or not, and that really is two different ways of thinking about the set. Disjoint events are never independent unless one of those events cannot happen. Okay. So we're going to fill in the formula here because our example is on the next page. The probability that A and B occur. I've got two different events. Independent events. That's the probability of A has happened, and then the probability that B has happened. We are going to multiply those probabilities together, and we're going to look at that example in a minute. Okay. So as we move on to page 8, we are going to talk about choosing cards from a deck with and without replacement. With replacement means after I choose a card and record it, I place it back in the deck. So I could draw it again. Without replacement means after I pick that first card, I do not put it back into the deck. And so it has reduced the number of cards that I have available at this point. So A wants 2 cards with replacement. The probability, I pull a turtle and a 2. So that is going to be the probability of drawing a turtle and the probability of drawing a 2. So there are 9 ways out of 25 to draw a turtle or a 2, and then if I replace that card, there's still 9 ways out of 25 to draw a turtle or a 2. I get a probability of 81 out of 625. Okay. B says we're choosing 2 cards without replacement. So we want the probability that we draw a turtle and a dog. So let's take a look at what we got here. Probability of turtle, I'm going to highlight that yellow now, and dog. There are 10 ways that I can choose the turtle and a dog. So I've got 10 out of 25. Without replacement, I am not putting that card back in. If I chose a turtle or a dog the first time, I now only have 9 cards to choose from on that second one out of the 24 that we have left. Notice I don't consider what happens if I did not choose a turtle or a dog on the first one, because that's not what we're interested in. If I want the probability of a turtle and a dog, that means that on that first draw, I had to have drawn one of those two. Okay, C, I want 2 cards with replacement. The probability that we draw 2 penguins. So here are my penguins, 1 through 5. The probability I draw that first penguin is 5. Sorry, I was reducing it already. 5 out of 25. I replace that card, shuffle them up. I still have 5 penguins in my deck, and I still have 25 cards. So I end up with a probability of 20 over 625. D, we want the same situations. We're going to choose 2 cards without replacement. Again, I want 2 penguins. So I have 5 penguins out of my 25 cards available to draw on my first draw. If I don't draw one of those, I'm done. I don't care what happens if I don't get 2 penguins. I want the probability I do get 2 penguins. So the 1 penguin I've already drawn is still out of the deck, which means I have 4 left out of the 24 cards because I've removed 1. And so I get a probability of 20 over 600. Example 12, we want the probability that you flip a coin 2 times and we get a head first and then a tail. I am going to go back to what our sample space looks like for 2 coin flips. I have head, 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 tail, 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 oops, tail, head, and then tail, tail. The probability of head, then tail, there's one way that can happen out of our 4 possibilities, our 4 outcomes. So the probability of a head and then a tail is 1/4. I'm going to roll a die 2 times in a row. What's the probability? I roll a 1 and a 4. Again, I am not going to worry about whether or not which order they happen in, if it's a 1 or a 4 or a 4 or a 1. But those are 2 possibilities out of my 6. And then when I roll again, 2 out of 6, remember the die does not remember what it rolled the first time. So I get 4 over 36. And I might reduce this one to 1/9.